Today we'll be solving quadratic trinomials by factoring with a focus only on the factoring aspect today. Today we're going to solve quadratic formulas by factoring, and for our content objectives for today, you need to be able to factor quadratic equations using the bottoms-up method. The way the bottoms-up method works is first we have to determine whether we can factor out a monomial, which is a number and a variable that's common in each term. Then we need to set up our x. After that, and this is the part where we make most of our mistakes, we need to find our two numbers that multiply to be the top number and add to be the bottom. Finally, we write our factors out and then bottoms up. So let's see how this works. If we take this equation here, step 1, we're supposed to factor out a monomial. So if I look at the numbers 6, 14, and 8, those are all divisible by the number 2. And that's the biggest number that goes into all three. Then I look at the variables, q squared, q, and then nothing. There's nothing common in the 3, since the 8 has no q involved. When we factor out that 2, factoring out means dividing. So 6 divided by 2 is 3, and then q squared. 14 divided by 2 is 7, q, and then 8 divided by 2 is 4. So we have this factor times this factor equals this. Now let's work with the x. When we fill in the x, we take the a and c of the new equation, so that's this one times this one, and we put on top of the x, so that's a times c. And we take b of the new equation and put that on the bottom. Next, we have to figure out the two numbers that multiply together to be 12 and then add together to be negative 7. And we can go through all the factors if we need to. 12 is 1 times 12, 2 times 6, 3 times 4, and then 4 times 3. Once we get to the two factors that repeat itself but are just switched around, then those are all the factors that we have. So the two that would add together to be negative 7 would be negative 3 and negative 4. Now that we have determined the two factors, we take a and divide both those numbers by a. Finally, we reduce both fractions, so negative 4 over 3 is already reduced, but negative 3 over 3 is negative 1. Second to last step is write out the factors. So we have q, because that's what we use here, and then minus 1, right, or the negative 1 here, and then q minus 4/3, which is what we have here. The last step said bottoms up, so we take the bottom or the denominator of the fraction and we move it up in front of the q. So we end up with q minus 1 and 3q minus 4, and don't forget the 2 that we factored out at the beginning. And if we want to double check this, we can FOIL it out or multiply it out. Q times 3q is 3q squared. Q and negative 4 is minus 4q. Negative 1 and 3q is negative 3q. Negative 1 and 4 is plus 4. Combine like terms here to get 3q squared minus 7q plus 4. Don't forget the 2 in front. And this is the same as this, so we know that we have factored it correctly. And remember that this part of what I just did is to check our answer only. That is not part of the actual solution. On to the next problem. So we look at all the terms, 5x squared, 17x, and 6. There's nothing common in the 3, so we go straight to the x. A times c on top, so that's 5 times 6 is 30. And then b goes on the bottom, that's negative 17. We can write out all the factors, 1 times 30, 2 times 15, 3 times 10, 5 times 6, and 5 times 6 will repeat itself after that. So we know the two factors that would add to be 17 are 2 and 15. Negative 2 and negative 15, because they have to multiply to be positive 30. Then we take a, divide both numbers by a, and reduce. The left one is already reduced. The right one reduces to be negative 3. So we write out our factors, x minus 2/5, and then x minus 3, and bottoms up. We take the 5 and move it out to the front. So we get 5x minus 2, and then x minus 3. Just like that. And again, we can FOIL it out or multiply it out if we want to determine whether our answer is correct or not. On to the next problem. If you like, you can pause this problem and try it on your own before I explain how to do it. So if we're trying to figure out if we can factor this, the first thing we need to do is factor out a common monomial, which we don't have because 3, 20, and 7 are only divisible by 1. So we fill out our x. 3 times negative 7 is negative 21, positive 20 on the bottom. So our two numbers that multiply together to get negative 21 and add together to get positive 20 is 21 and negative 1. Next we divide by the a. So 21 divided by 3 is 7, and negative 1/3 is already reduced. So we end up with x plus 7 and x minus 1/3, and then bottoms up. So we end up with x plus 7 and 3x minus 1. And we're done. On to the next. Again, you can pause this problem if you like and try it out on your own before I go over it. So if we look at all three terms, there's nothing I can factor out of all three, so I fill in the x. 4 times 5 is 20, 12 on the bottom, so my two numbers are going to be 2 and 10. Then I take a, divide both of them by a, and reduce. 2 over 4 is the same as 1/2. 10 over 4 is the same as 5 over 2. Right? And then we write out our factors. X plus 1/2, x plus 5 over 2, and then bottoms up to get 2x plus 1 and 2x plus 5. Again, you can pause the video and try this one on your own. Otherwise, we look at all three terms. There's nothing I can factor out of any of the three. So we fill in our x. 4 times 2 is 8, negative 9 on the bottom. So my two numbers that multiply together to get 8 and add together to get negative 9 is negative 8 and negative 1. Again, we divide by the a. Negative 8 divided by 4 is negative 2. So we write out our factors, x minus 2 and x minus 1/4, and then bottoms up. So we get x minus 2 and 4x minus 1. Now we have a case where a, there is no a is in fact 1. The process is still the same. There's nothing I can divide out of any of the terms. So we fill in our x. 1 times negative 18 is negative 18. Negative 3 on the bottom. So our two numbers are going to be negative 6 and positive 3. In this case, I would divide by 1, but when I reduce that, that's just 3 and negative 6. So our two factors are going to be x minus 6 and x plus 3. Now as we do this problem, there's nothing I can factor out of all of them, including this one. Make sure you look at all three terms, not just the 3 and the 12. So I fill in my x, I get negative 12 and positive 3, and then I try to figure out all the factors. So 12 is 1 times 12, 2 times 6, 3 times 4, and then it repeats back around. But if I look at each one of these factors, there's no way I can add any of these to get positive 3. So because I have listed out all the factors and have proven to Mrs. Kanaly that there are no other factors possible, this one is not factorable. So when we do this one, a is 1, b is 0 this time, and c is negative 49. There's nothing I can factor out of both, so I fill out my x with negative 49 on the top and 0 on the bottom. Anytime we have 0 on the bottom and a negative number, that's a perfect square on top. In order to get the two numbers, we just have to take the square root of 49. So that's 7 and negative 7. And in this case, a is 1, so I end up with just 7 and negative 7. So I get x plus 7 and x minus 7. So there's nothing I can factor out of any of these, so I set up my x, 64 on top, 16 on the bottom, and the two numbers that multiply together to get the top one and add together to get the bottom is 8 and 8. Again, a is 1, so we end up with x plus, or I'm sorry, not x, we get y plus 8 and y plus 8, which if we rewrite it is y plus 8 squared. Either of these answers is correct. So for this one, we look at each one of the terms, and each one is divisible by 3. So if I take out a 3, I get x squared minus 4x minus 32. Remember that we divide each number by the greatest common factor. And then now I factor just the part in the parentheses. So I put negative 32 on top, negative 4 on the bottom. So my two numbers are going to be 8 and 4, with the 8 being negative because the bottom number is negative. And there is no a, remember, the 3 is outside of the parentheses now, so the a is 1. So if I divide both by 1, don't forget the 3, I get x minus 8 and x plus 4. So for this problem, again, there's nothing I can factor out of both. So a times c is negative 16, and b is 0 because there is no x by itself. Our two numbers are going to be 4 and negative 4. Don't forget to divide by the a and reduce. The left becomes 1/4. The right becomes negative 1/4. So we get x minus 1/4 and x plus 1/4, and then bottoms up. So we get 4x minus 1 and 4x plus 1. We're going to skip this one. On to the last one. There is something that I can factor out of both. Both are divisible by 5, and I'm going to be left with x squared minus 9. So in my x, I have negative 9 on top and 0 on the bottom, which gives me 3 and negative 3. Remember that a is 1. So I end up with 5, don't forget the 5, and then x plus 3 and x minus 3. Now your homework is a worksheet which is available in the back of the room in the Algebra 2 folder, and you're only going to do the front part, the x part only, because tomorrow we'll deal with the back part of the worksheet.